All right, so before we get to the final hypothesis test, just a couple of, a little bit of housekeeping here. So we do have our final exam that is coming up. So the final exam is going to be due during the exam week. So ours happens to fall on Tuesday, December 11th. It's going to be during class time. It's going to cover confidence intervals and chapter 10. So that is all that's going to be on there, calculating confidence intervals for the three different scenarios that we looked at: single sample t-test, dependent means t-test, independent means t-test, and then doing ANOVAs, which we're going to cover today. So that's what's going to be on the final exam. It's really just exam number 4. It's not cumulative, and it's not going to be any larger than your previous exams either. So the format, no change, computational exam. It'll be available in Canvas. It's going to have 7-ish questions. I'm finalizing the questions as we speak, but it still will be open book, which means open everything except other people. So once again, whatever materials you need to bring, whatever materials you want to make in advance to help you prepare, feel free to do that. All that matters is that you do your own work and you can get the hypothesis tests done. So take advantage of that. No need to memorize the steps or anything like that. But again, use it as a reference, not as a learning tool, because if you try to learn anything about confidence intervals or ANOVAs during the exam, you will not finish the exam, so don't let that happen to you. And then we're still having a review session. We're going to have an open review session next class. And as always, this is going to be student-driven. So bring your own questions, bring your own anything that you might want to see. It's going to be student-driven. And because of that, once more, it's completely optional. So if you want to take that extra time to prepare in a different way, feel free. But I will be here to help anyone who attends get ready for that final exam. All right. And one other thing to just call attention to, you do have a exam template in terms of what it is that you will be coming up on in terms of the exam, and that is available in Canvas. So just to kind of highlight a little bit of what that includes. So all right, so you do have this final exam template, and this is what your two questions will look like. So there's 2 types of questions that'll be spread throughout the exam. 3 or 4 of them are going to be confidence intervals. So much like your homework, you're going to have the confidence intervals. What's the point estimate? Calculated 95%, calculated 99%, and you have to put it in the form of the point estimate plus or minus a certain interval. And then the other ones are going to be hypothesis tests for ANOVAs. So again, you'll get the description. You'll be asked, or you'll be indicated which post hoc test to do, and we'll talk about those today. And then for the hypothesis test, you won't be asked for the null hypothesis or the research hypothesis because those are standard for ANOVA. So I will provide you with those. You don't need to come up with those on your own. But you will have to find the degrees of freedom for between treatments and within treatments. You will have to find the alpha level, the p-value. You will have to decide whether to accept or reject the null and research hypotheses. And then finally, you will have to do post hoc analyses and determine which pairs of conditions are different. And again, that's part of what we will be looking at today. All right, so back to our question, our comparative psychology question. So once again, if you're interested in comparative psychology and you want to know the behavior of animals and how they operate, one of the weird things that certain animals do is migrate. So certain birds migrate massive distances. So the Arctic tern migrates all the way from, almost the North Pole to the South Pole. Other birds do not. So researchers were wondering, does this have anything to do with the intelligence of birds? Maybe the smarter you are, the more you're able to survive in any environment, so you don't have to go through that ordeal of migrating. So they took the sizes of different birds, measured their relative brain size, came up with a score to see if non-migrating birds like the blue jay are actually more intelligent than birds that migrate massive lengths, such as the Arctic tern. So what we're going to do today is we're going to take a look at how to do the independent means ANOVA in SPSS. We've already taken a look at the logic behind the independent means ANOVA. That was a special online class, so if you did not see that one yet, please make sure that you view that sometime before the exam. And then I'll just mention homework assignment number 14 and some stuff about the post test, and we'll have some extra practice opportunity. All right, so the independent means ANOVA. Here's the situation, here's the experiment. One possible explanation for why some birds migrate and others maintain year-round residency in a single location is intelligence. Specifically, birds with small brains relative to their brain size are simply not smart enough to find food during the winter and must migrate to warmer climates where food is available. And that's an actual study done by Saul Lefebvre and Rodriguez Tijerio. Birds with bigger brains, on the other hand, are more creative and can find food even when the weather turns harsh. The following are hypothetical data similar to the actual research results. The numbers represent relative brain size for the individual birds in each sample. We're going to use an ANOVA with an alpha of 0.05 to determine whether there are any significant mean differences among the three groups of birds to see if they have different brain sizes depending upon their migration. So we have the following data. We have birds that do not migrate. We have birds that migrate a short distance, and then we have birds that migrate a very long distance. And these are the relative brain sizes for the non-migrating birds. Here are the relative brain sizes for the short distance migrating birds and the relative brain sizes for the long distance migrating birds. And we want to know whether or not these mean differences indicate a real difference between the brain sizes of the population of non-migrating birds, a real difference between the brain sizes of the population of short distance and long distance migrating birds. So again, we can't do this with a t-test and just do multiple comparisons because that inflates our chances of a type 1 error, that inflates our chances of saying that there is an effect when there actually isn't one. So we need to do an ANOVA. So luckily for the ANOVA, same 5 steps. So the same 5 steps that we've been doing this whole time are the same 5 steps that we do for the ANOVA, slight little tweak. So for example, for the research hypothesis, do birds that migrate have shorter distances? Do birds that migrate shorter distances have bigger brains? That's the question that we're asking. We have to put it in the form of a null and a research hypothesis. For an ANOVA, it's only a two-tailed hypothesis test. That's the way that an ANOVA works. So you won't be asked to do a directional ANOVA. You're only ever going to be asked to do a two-tailed ANOVA. In fact, you will not be asked to do a two-tailed ANOVA. You'll just be asked to do an ANOVA. So what that means is that when you restate the question as a research hypothesis and a null hypothesis about the population, the null hypothesis will always be that every population is equal. So in this case, the null hypothesis is that the brain sizes are not different for birds that migrate different distances, and that is written as the mean size of the brain for non-migrating birds equals the mean size of the brain for short distance migrating birds equals the mean size of the brain for long distance migrating birds. So we have 3 groups, and the null hypothesis is that the mean for each population is going to be the same. So that's the null hypothesis. The research hypothesis is the complete opposite of the null hypothesis. So the null hypothesis is that all 3 population means are the same. The research hypothesis is that at least one of them is different. And this covers every other possibility. Maybe it's only the non-migrating birds that are different. Maybe it's only the short migrating birds that are different. Maybe it's non-migrating and long distance migrating that are different than the short distance, but they're not different from each other. Basically, at least one of them is different. So the null hypothesis is that they're all the same. The research hypothesis is that at least one of them is different. Could be just one, could be 2, could be all 3, but at least one covers all of those scenarios. All right, so that's the null and the research hypothesis. Next, we have to determine the characteristics of the comparison distribution. This is now an F distribution. Luckily, SPSS will do this for us. Step 3, set a cutoff probability. This has not changed. The logic of this has not changed. This is still our alpha level. That's still our cutoff probability. It's still given to you in the question, and most of the times it's still going to be 0.05. So this has not changed whatsoever. and then determine your sample's probability on the comparison distribution. This is slightly changed, but we're still looking for that p-value, and SPSS will still calculate this for us. All right, so let's start. We'll start to do that right now. So the data that we're going to be used can be found in number 31, practice December 4th in chapter 10. And as always, there's going to be screen grabs that kind of lead you along as you go through. But let's do this live. So we will close the final exam template. And this is the data that we're looking for. So these are the data for the bird brains. Let me zoom in on those. All right, so once again, relative brain sizes for non-migrating birds, relative brain size for 6 different short distance migrating birds, relative brain size for 6 additionally different long distance migrating birds. All right, so recall that this is an independent means ANOVA. So it's much like an independent means t-test, and we're going to set it up pretty much the same way. So the first thing we need to do is we need to copy our non-migrating birds, and we take those and we're going to paste them into row number 1, column number 1, and man, I'm up to 13 variables already. All right, so that's the 13th variable for me because we did exam number 3, but we still just want to change that. And let's just change that to brain.
Where would the data be found of the bird?
It should be in Canvas in Excel sheets. It's not. All right. Fun times. Let's pause the. All right, so unpause as if nothing ever happened. Okay, so we have our scores for the non-migrating birds. And we're going to set this whole thing up like a independent means t-test, which means that we're going to have one column that has the brain sizes for our birds. And then we're going to have one column that indicates what group they belong to. Now, the one thing about this is that the column that we use that has the groups that these birds belong to, we cannot do it in the typical way that we've been doing it so far. So far, what we would do is we would say, all right, let's call these ones non-mig for non-migrating. And we'll just copy that. And we'll paste that all the way down. And we can call this distance. Yeah, and that's 8. All right, so we got non-mig. Right, and that's the distance that they migrate. All right, so next we get the short distance, and we copy those. And remember, these are 6 new birds. Right, this is a separate sample. They get their own rows, so they go in right underneath. Their brain sizes go in right underneath the non-migrating birds, and we're going to call these ones short. All right, and then finally, you probably already guessed this, but we go to the long distance migrating birds. We copy their brain sizes. We go to SPSS, we paste it in, and we can call these ones long. All right, so this would normally work, and this was the way that we did this for the independent means t-test. Setting it up for the ANOVA is exactly the same. There's just one little difference, and that is that you cannot give word names to your groups. Don't ask me why. This is like a 1990s programming holdover for some reason, but you cannot call your group non-migrating. You cannot call your group short. You cannot call your group long, the same way that we did it with an independent means t-test. So the last thing that we're going to have to do is we're going to have to make one more variable, and this variable is going to be full of numbers that indicate which group is which. So I highly recommend that while you're doing this, and this will help you out, on a sheet of paper somewhere, just write down who is what group. So we're going to call them group 1, 2, 3, and we're going to call group 1 is going to be the non-migrators, Group 2 is going to be the short distance migrators. And group 3 is going to be the long distance migrators. And what we need to do in our output here, or sorry, in our input here, is put those numbers next to our groups. So we label all the non-migrating birds as being part of group 1. We label all the short distance migrating birds as being part of group 2. And we label all the, whoops, we've gone one too far. We label all the long distance migrating birds as being part of group 3. And this, what I just did, is a great example of why you should always check that top table and make sure that you have the right number of subjects in each group. Because especially when you're doing this, the chances of doing something like this, where you put in group 2 one too many times, and you have this error right there, where you put a long distance migrating bird into group 2, the chances of that happening is higher than it's ever been before. So because of that, always double check that top table to make sure that in this case we have 6 subjects in every single group. So remember to do that. This is a new thing, and we're going to call this, bless you, we're going to call this group. But this is a new little wrinkle that we need for the ANOVA. So again, I mentioned this, and I'll mention it one more time just so that it sticks. It used to be fine for a t-test to name our groups using words. And that's why it throws some students off sometimes, because you're so practiced on the t-test, you get to this situation, you're like, oh, it's like the same thing. There's just one little 1990s extreme programming hangover that they have here, and that's that you have to number your groups. So if, again, you're doing your test and it doesn't work out and it doesn't allow you to run it, double check to make sure that you've numbered your group somewhere. And write it down. You will be astounded at your brain's ability to forget which group is which when you're dealing with the post hoc analysis. So I highly recommend that you write it down. All right, so now we're ready to go. So we go to analyze. We still go to compare means, right? Because we're comparing means. We're doing it by comparing variances, but we're still comparing means. And very nicely, there's the ANOVA that we want to do. So we still go to the same menu selection. We still go to the same menu location, analyze, compare means, but it's that one-way ANOVA. That's what we want right now. So we click on that. And then for the one-way ANOVA, we have our dependent list, and then we have our group here. Sorry, we have our brain scores, and we have our group scores. The brain scores, that is your dependent list. So your dependent list are the measured scores. They're your raw data. So we take brain, and we pop it into dependent list. You'll notice just before we do that, my computer's running out of power. But anyways, you'll notice just before we do that, that we only have 2 variables that are being shown, right? We only have 2 variables to select from. Distance is gone. We can't even choose distance for this analysis. So again, if you get to this point and all you have is brain and you got nothing else, double check that you've numbered your groups. So brain, our raw data, that goes into this dependent list section. Group goes into this factor. And you'll notice that there's no define the groups like there was in the independent means t-test. That's one of the reasons why it has to be numbered. All right, so we got our one-way ANOVA set. The last thing we want to do is we want to go to post hoc over here, and we want to click on that, and it'll give us a number of different post hoc or after the fact tests that we can do. So for this one, we're going to choose, let me see if there was a specific one that was mentioned. For this one, no, for this one there wasn't a specific one mentioned. For the exam there will be, but for this one there's no specific one mentioned. So we'll use the Tukey. That is the Tukey honestly significant difference post hoc analysis. And we'll talk about why we need these when we get to the post analysis of the ANOVA. One thing you never want to do when you're doing these, there's different ones that are good for, they have their own pros and cons. The one thing you never want to do is click on all of them. You might think, well, I'll just be very thorough. I'll try them all out. You'll end up with an 80-page output and you won't know where to look. So choose 2 at most. And when you get to grad school, you'll learn the difference between the Tukey, honestly significant difference, the Bonferroni test, the SIDAC test. But just choose one of those. And then the last thing we want to do before we go ahead is we want to take that significance level and we want to change it to our alpha level. And doing that just gives you one last little double check. It just gives you one last little safety net when you're interpreting your statistics. So we go back to our question here. We see that it says use an ANOVA with 0.05. So when we're doing our one-way ANOVA, we want to make sure that the significance level there says 0.05. So once we have that set, Tukey, honestly significant difference, significance level 0.05, we hit continue. Once again, that's in this post hoc analysis section. And then once we've done that, we hit OK. We hit OK. There we go. And we have our ANOVA, and it's been run. So pretty quick. We have our output here. So let's take a look at now where we can find our output. And there's one last little thing I forgot to do. Sorry about that. It's been one of those days. If we go back to ANOVA, luckily it's all set up. You actually are going to want to hit that options, and you're going to want to hit descriptive. These are your descriptive statistics. This is the number of subjects you have in each group, number of what's the mean in each group, what's the standard deviation in each group. So you're going to want to hit that descriptive one. So again, we have the raw scores in the dependent list. We have the group numbers in the factor. Post hoc, we've chosen, in this case, the Tukey, honestly significant difference. We've set our significant level to our alpha level as our safety net, our double check. And then also in options, we've chosen descriptive statistics. And that's going to give us how many subjects in each section and what's the average for those. It's going to give us those descriptive statistics. We hit OK, and now we got the ones I was looking for. We got those descriptives. Good, we're ready to go on. All right, so let's take a look at the output that we have here. So things that we need to do. So we have our null hypothesis, we have a research hypothesis. Next thing we need is to determine the characteristics of the comparison distribution. So step number 2, you're going to want your degrees of freedom for your between groups, and you're going to want the degrees of freedom for within samples. So they'll call them within groups, within samples, between groups, between samples. The key thing that you're looking for is the within and the between. So I believe your textbook calls it between and within samples. SPSS, you'll see it right here, between and within groups. So before we get to that, again, check your descriptives. We can see that we have 6, importantly, 6 birds in every single group. That means that we didn't number it incorrectly when we were doing that really quick 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, 3, 3, 3, 3, 3 thing. You can check the means. The means are correct. That means that we didn't copy and paste anything incorrectly in that way. So again, this is just a quick double check to make sure that something didn't go horribly wrong when you were copying and pasting. Next thing we need is we need the between groups and within the within groups degrees of freedom. For that, we go down here to where it says ANOVA, and we can find it's very nicely labeled in this table. There's the between groups, there's the within groups. Again, in your textbook, it calls, in other places, you might see it between samples, within samples. Same exact thing. What you're looking for is that between and that within. And we find our degrees of freedom, and there are the degrees of freedom. So the between groups, degree of freedom, we got 2. The within groups, degrees of freedom, we got 15. Notice that that adds up to the total degrees of freedom for the total variance, which in that case is 17. But importantly for us, degrees of freedom between and within, we get that right. We got that right there off the table. All right, so we got 2 between treatment degrees of freedom, 15 within treatments, degrees of freedom again, within treatments, between groups. Just look for the between and the within. That's the key difference. All right, so we got part 2. Now we need to get the data, the output that we need to make our decision on whether to reject or accept the null hypothesis. Once again, exact same rationale as we had for the t-test. If your p-value is less than your alpha, you accept the research hypothesis and you reject the null hypothesis. If, on the other hand, the p-value is greater than alpha, we accept the null hypothesis and we reject the research hypothesis. So that has not changed. So we look for our significance. Once again, we're back here in our ANOVA. For your homework, they're going to be asking you for an F statistic. That's your F statistic right there. So SPSS will calculate out your F statistic. When you report an F statistic, you have to report the degrees of freedom. SPSS will give you that as well. So just so you know where to look, that's where you find the F statistic for your homework assignments. For us, however, in the real world and in the upcoming exam, we're looking for that p-value. And that p-value that we're going to compare to our alpha value is right there. It's that significance. So this one is very, very small. Right? The p-value is basically 0. So that's our p-value. And remember, for an ANOVA, there's no one-way test. ANOVAs are always two-way. So this is much more straightforward. We don't even have to make the decision. We just read that p-value straight off of our output. So we need to now decide whether that p-value is less than alpha. If it is, which it is, we accept the research hypothesis and we reject the null hypothesis. If it isn't, we would do the opposite, accept the null hypothesis and reject the research hypothesis. Turns out our p-value is 0.000. Our alpha level is 0.05. P-value is much less than our alpha level. So we end up rejecting the null hypothesis. And we figured that at least one brain size is different for birds that migrate different distances. So this is the end of our ANOVA analysis. And while it is informative to know that there is a difference, notice that so far the ANOVA has not told us which difference is the one that is the difference. And you can imagine how useless this would be in many situations, and in this one as well. So let's say that you are working on a new drug to treat cancer, and you give subjects a placebo, and you give them drug A, and you give them drug B, and you give them drug C. And you run an ANOVA on the cancer rates for these 4 conditions, and your ANOVA comes back and your p-value is 0.00000. So you reject the null hypothesis. You reject that the effect of all of these drugs is the same. And your supervisor comes in and he says, oh, I heard it was significant. And you're like, yes, at least one of these drugs is very effective at fighting cancer. And he's like, great, which one is it? And you're like, I don't know. ANOVA didn't tell me, but one of them is. Isn't that wonderful news? Well, yes, but we're not quite there. So we're in the same situation here. We know that one of these, at least one of these birds, has a bigger brain size than the other populations. But which one? And which ones, possibly. So for that, we need to do one extra step. We need to take a look at those post hoc analyses. And that's what we're going to be doing right now. So step 5B, once you find that there is a difference, right? If there was no difference, if we accepted the null hypothesis, we'd be done, right? We would know that the mean brain size in each population was the same. But we rejected the null hypothesis. So we know at least one at least one of those populations has a bigger brain than the other ones. Maybe all 3 of them are different. We need to find out. So that's what we do now, post-analysis, aka post-hoc analysis. So which brain sizes are different than the others? We want to know, is the non-migrating birds, do they have different sized brains than the short distance migrating birds? Do the non-migrating birds have different sized brains than the long distance migrating birds? And then finally, do the short distance migrating birds have different sized brains than the long distance migrating birds? Those are the only three differences that could be occurring. So we want to know which one of those happened, which one of those was driving our research hypothesis that we found. So for that, we got to interpret the SPSS output, the post hoc tests. So the post hoc tests, they're the table directly underneath your ANOVA table. So that's what the post hoc test is when you zoom in on it. And one thing to remember about the post hoc test is that it is overly redundant. And I'll point that out in just a moment. So part of it is not that friendly. It's overly redundant. Part of it is friendly though. So for example, it indicates which group is being compared to which other group. First off, it reminds you what comparison you did. So we did the Tukey honestly significant difference. It labels it. It says, hey, you did a post hoc test. There's your table. And you did the Tukey just in case you forgot what it was. The first column here indicates which two groups are being compared. The second column indicates the difference between those two groups. And then the third column indicates whether it's a significant difference. It indicates the p-value associated with that comparison, right? It's literally like doing a independent means t-test, but these tests control for expanding that error rate. So it's a post hoc test that kind of keeps everything from ballooning out of proportion. So those are the three columns that we're going to be looking at. So what do we want to know? Well, take a look at that first row there. What SPSS is saying is that it took the brain size of group 1 and compared it with the brain size of group 2. This is where this comes into play. Because without this, you're going to have to juggle so much in your brain. You're going to have to sit there going, okay, group 1 versus group 2. The difference is 6. Group 1 was non-migrating. What am I comparing? Group 2 was short, so non-migrating. It's easy to lose yourself. So write it down. And especially, going the other way. If you want to know what's the difference between non-migrating and short migrating, you want to compare group 1 to group 2. So we find it here, group 1 versus group 2. The difference in brain sizes is 6 points. So group 1 minus group 2. So group 1 has a higher brain size than group 2. But what we're looking for is this significance value right there. And that significance value tells you that the difference between group 1 and group 2 is significant, is a real difference. So it works just like an alpha level. So you have an alpha it works just like a hypothesis test. You have an alpha of 0.05 that's given to you in the question. This comparison has a p-value of 0.003. P-value is less than alpha. It's a significant difference. And you remember that double check that I told you about? That shows up here in that asterisk right there. Because if you entered in the correct alpha level, SPSS will put an asterisk next to every mean difference that is significant at the alpha level that you chose. So you should use this as a double check. So check the p-value. That p-value is less than your alpha level, so we should reject the null hypothesis. Lo and behold, there's the asterisk saying, yep, the mean difference is significant. We're rejecting the null hypothesis. So that's for non-migrating compared to short migrating. So we know that non-migrating, the mean size of non-migrating bird brains does not equal the mean size of short distance migrating bird brains. That's at least one difference that we found. So that's one of the reasons why the ANOVA, the initial ANOVA, was significant. Next, we want to know about non-migrating versus long distance migrating. We want to know group 1 versus group 3. So in this, the one little thing that sometimes gets a little bit confusing is we can see this column number 1 here, and it has group 1 blank, group 2 blank, group 3 blank. And what SPSS is doing, and I don't know, again, this might be a holdover from the 90s, it's trying to save code or save ink or I don't know what, but it's assuming that this 1 carries down, this 2 carries down, this 3 carries down. So I don't know why I just wouldn't print another 1 right there. It would make things a lot easier. But this top row is group 1 versus group 2. This second row is group 1 versus group 3. That's what we want. We want group 1 versus group 3. Notice I mentioned that it's redundant, just in case you didn't find that row right there. You also have group 3 versus group 1. So don't get confused. You're only ever going to use half the table. They have it in multiple places. So this is group 1 versus group 3. So group 1 is 9 points higher than group 3. Or comparing group 3 to group 1, group 3 is 9 points less than group 1. So it is redundant. Don't let that throw you off. Importantly, we go over to that p-value, that significance. Significance is 0.000. Compare that to our alpha, which is 0.05. We reject the null hypothesis. We say that this is a real difference, much like in a t-test. And lo and behold, we scroll across and we see that asterisk. So SPSS has double-checked our conclusion. We think it's significant. We're going to reject the null hypothesis. SPS says, yep, there's your asterisk. Yep, significant at your 0.05 level. All right, so we can conclude that non-migrating birds have different brain sizes than long-distance migrating birds. Specifically, they have larger brains than long-distance migrating birds. All right, one last comparison to do, which is the short-distance versus the long-distance migrating birds. So we go back to our table and we go back to our little notes here and we say, all right, we want to compare short distance to long distance migrating birds. That's group 2 versus group 3. So we got to find group 2 and group 3 somewhere. There's group 2 versus group 3. Once again, don't let the blank throw you off. This entire 2 rows is group 2. So we got group 2 versus group 3. Brain sizes of group 2 are 3 points higher, but we go over to this p-value here, and notice we got a p-value of 0.138. We compare that to our alpha of 0.05. Our probability is larger than our alpha. That means that we accept the null hypothesis. We say that there's no difference between the brain sizes of short and long distance migrating birds. And we scroll over to this mean difference and notice SPSS has no asterisk there. So again, it's double checking our conclusions. We say that there's no difference and SPSS says, yeah, no asterisk, no difference on that one. So use that SPSS double check to kind of help you out. But for that to work, you have to, in your post hoc setup, make sure that you're using the right alpha level. All right, so we know that for this, the mean brain sizes of short distance birds equals the mean brain sizes of long distance migrating birds. So the final analysis is basically the brain sizes of non-migrating birds are different than the brain sizes of any bird that does migrate. But the 2 birds that migrate, it doesn't matter if you're a short distance or a long distance migrating bird, you are not as intelligent as the non-migrating birds. All right, so that was the ANOVA. That's the end. That's the final analysis. And you will be asked to do both of those, both the ANOVA and the post hoc analyses. And just one more thing to mention, and let me bring up the practice exam here, or the template for the exam. Where'd that thing go? Here we go. All right, one last thing to mention. You will be told what what post hoc test to use. So you'll be given the alpha, you'll be given the post hoc test to use. Sometimes it'll be Bonferroni, sometimes it'll be Tukey. So make sure that you pay attention to that. And then you will be asked for whether or not there's a significant difference between the different populations, but you won't be asked for all of them. So for three different populations, there's 3 different comparisons. Sorry, there's 3 different possible comparisons. For 4, there's 6. If there was 5, there'd be something like 10 comparisons. So we're not going to do like a marathon of comparisons. You'll be asked for specific comparisons. So make sure that you make a note of which group numbers those are. And then on the output, make sure that you can find those, find the correct row so that you can make that determination, get that significance level compared to your alpha, and then use SPSS asterisk to double check. All right, that is about it for today. So let's just wrap this up. So real quick, homework assignment number 14, chapter 10. That is another MyLab, your final MyLab homework assignment. That is due December 5th at 11:59 p.m. For anybody that has not submitted their confidence level homework yet, be sure to get that in as soon as you can. That was due midnight that just passed. So make sure that if you haven't uploaded that yet, go to Canvas, upload your completed Excel sheet. The Chapter 10 post-test is going to be due Friday, December 7th at midnight. So that gives you the opportunity to complete your homework, get your feedback, come in for the review session on Thursday, and then you'll have the rest of Thursday and the entire day Friday to complete your post-test. And that will give you the entire weekend plus Monday and half of Tuesday to prepare for the final exam. So just be aware of that due date there. And as always, I will be updating these, I promise, just a little behind because of the whole missed week. But if you did not receive 100% on the Chapter 10 pretest, you can still achieve 100%, complete the mastery points, and I will take the maximum of what you got on your pretest or what you got on your Chapter 10 mastery points. And that is due December 10th at 11:59, basically the day before the exam. So just a few due dates coming up that you should be aware of. All right. There was some in-class practice. So you do have the question on keyboard designs. So you can try this out before you need to do your homework. We have 1 minute left. So if anybody wants to leave early, sorry about it, took so long. But basically, that is all that I wanted to cover today. So you now know how to do analysis of variance. You know how to do post-hoc tests. Thursday is going to be a review session. Tuesday is the exam. Other than that, we are done for today. So thanks for coming out. And I will see those of you that come on by at the review session.